Okay, for this screencast, we're going to review the solutions to the quiz review sheet. And just a reminder that you should be looking at really three major things when you're preparing for the quiz. Number one, definitely this review sheet. The second thing you really should be using is your textbooks, and specifically pages 128 to 140, and those are the only pages that you'll be quizzed on. And the third is screencasts. And there are a whole series of them on simple machines, as well as this one here on the solutions. All right, so with that being said, let's go on ahead and let's kind of start reviewing the solutions. The first question is, what is a mechanism? And this is a question that's taken straight from your textbook. This answer is found, actually, if you want to refer to it, on page 128. And what the textbook says is a mechanism is made up of several different types of machines that work together to perform a specific function. Okay, so a group of machines that work together to perform a specific function. So for example, it could be a laptop. Okay, all these different machines and parts inside it, simple machines, work together to allow you to do your work. Another example of the textbook gives is a bike. So a bike has gears, has levers, has wheels and axles, and those all work together to allow you to get from one point to another. Now, number two, and again, this is taken straight from your textbook, so if you want to refer to the solutions, it's on page 131, and it gives all 6 types of simple machines. Okay, there's a lever, there's a wheel and axle that's given, there's an inclined plane, there's a screw, there's a wedge, and of course there's a pulley. And the sketches are also found on page 131, so please check your textbook for a little bit more information. Now for number 3, again, giving you the page numbers where you can refer to this information, you can refer to pages 132 to 133. Okay, extra P there. Now, these pages detail the 3 different classes of levers, but let's just go with what the question says. It asks for second versus third class levers. Now, just kind of sketching it out, this is not a point of difference. The fulcrum for both of them are located on one end, but for second class levers, this is where it's different. So one difference is, let me include it here. Is that for second class, you see from the diagram the output, which is right here, is located between the input and the fulcrum. All right, and I mean, just to explain with words, a third class input is between output and the fulcrum. Okay, and you can also see from this diagram, your input is in the middle, output and fulcrum on either end. Now, the question here doesn't ask it, but if it were to ask for similarities, what could you say? You could say number 1, fulcrum on one end. So what you can see here, this is on one end, this is on the same end, it's not in the middle. And the second similarity is F in, F out are in the same direction. So you can see here the arrows are both going in the same direction there, okay? But to respond specifically to that question, really the only difference is that the output is in the middle for second class, the input is in the middle for first class. Now, for a real life example, let's just switch to black. This one here, for a second class lever, it'd be a bottle opener. And for the third class, you could say, let me see, let's go with hockey stick. Okay, and so that is the solution for question 3. Now let's go back to blue and go to question 4. It says, what is the IMA of an inclined plane that has a length of 6 meters and a height of 1 meter? Now, this is where you have to start applying your formula. So IMA, you have a whole bunch of formulas for this. For the IMA for an inclined plane, if you want to refer to your textbook, I'm just flipping to it right now, it's on page 139. And what that page says is the IMA of an inclined plane is the length over the height. So let's check the units. Great. Both of them are in meters. So I can put 6 over 1, which is equal to 6. And that is good. That is totally good. There's no units for it. Okay. Now, blitzing through this, question 5. This is one of those a little bit longer. It says, refer to the diagram to answer the question. So if I can sketch the diagram very briefly. Okay, so this is kind of what it looks like. Okay, let's go with black. The question says, the lady's left hand does not move. So here, if this doesn't move, that's the fulcrum. You can imagine if you're in that position, that would be your left hand. The right hand is pulling the rake towards her. So what that means is the input is in that direction. What else do I know? Oh, well, I guess based on that, the output is, if you're pulling the rake towards her, the output is the rake actually goes towards her. Now a few other measurements. The distance from her left hand to her right hand is 63 centimeters. So this one here is 63 centimeters. And the distance from her right hand to the end of the rake is 87. So let's draw this here. 87 centimeters. Hopefully you can make that out. Now for part A, let's go back to blue here. Let's just do it up here. It's more space. Part A. What class of lever is she using? Well, let's have a look. The fulcrum's on one end, so it has to be either second or third class. Now, the input is in the middle. So if the input's in the middle, it has to be a third class lever. And one final check, for it to be a third class lever, the input and the output have to be in the same direction, and that is true. So if I ask you to explain it or justify it, you could justify it using fulcrum. You could justify using, let me see, location of input, output, and you could justify it using direction of the input and output. Now the question doesn't ask you to justify it, but if I do, these are actually 3 different ways that you could justify it. So fulcrum, location of the input and output, and the direction of the forces. And if you want more information on these, please do refer to the screencast on levers. Okay. Now let's get to part B. It says, what is the ideal mechanical advantage of the woman raking her lawn? Now this part here, it's good. We only really have one formula for it. Okay. But we do have to do a little bit of thinking here. Now the formula is the IMA is equal to the length of the input arm over length of the output arm. Now let's do some thinking here. The input distance is the distance from the fulcrum, right here, to the, let me highlight, the distance from the fulcrum to the input force. So that distance there is simply 63 centimeters. Now the output is the distance from the fulcrum to that same spot, but to the distance of the output force. So that's going to be actually 63 plus 87. Okay. Oh, let's switch back to blue. And if I simplify that, I basically get 120. Okay, so let me get my calculator out to do that. It's about 0.5, but let's be exact. So what I have is 63 divided by 120, which equals 0.525. Now, a few of you ran into issues about rounding, so you could put this as 0.5. That would be good. The long one's also good. You could also put 0.53. Okay, that'd also be good because you're rounding up the 2, because that is a 5. Okay, and again, there are no units. Now, let's finish off part C right here. It says, where should she place her right hand if she wants an ideal mechanical advantage of 0.5? So we're really keying in on, let me see, let's use black. Her right hand is, maybe I should change that question to left hand. Nope, that's correct, right hand. So her right hand is this one here. So where should she move it? Now let's do some thinking here. In terms of the ideal mechanical advantage, I want that to be 0.5. Okay, so I basically want something that's twice on top, twice that's what's on the bottom. Okay, now what is the total distance I have? I actually have 87 plus 63. That gives me 120. So I want to try and do some thinking here. This is not the easiest, but think of how I can split up 120 so that what's on top will be twice what's on the bottom, and that way I'll find that 0.5. Okay. Do a little bit of trial and error, but if I do that, what I end up with is if I have, let me see, 80 on top and 40 on the bottom, right? Because those two will add, let me see, 80 plus 40 equals 120, that's great. If I divide that, I do get 0.5. So therefore, her right hand, and again, if this is the input distance, let's see, oops, sorry, the length of the input should be 80 centimeters from the top of the rake. Okay, and hopefully that helps. Stay tuned for the next screencast for the rest of the solutions.